Hello everybody. In this video we will discuss reaction of an acyl chloride with a nucleophile such as CH3O- or alcohol, or we will look at some of the amine as well. So we know that in the carbonyl group in an acyl chloride, well, what's an acyl chloride? It's a carboxylic acid derivatives when you have your carbonyl group is connected to a chlorine. Again, it doesn't have to be chlorine. If you have bromine, then it's going to be acyl bromide. So when you have something like this, it's going to react with a nucleophile. So how it will react? We know that the carbon atom here has a delta positive charge. So that is, when something is positive, it's gonna love electrons. So it's an electrophile. So this carbon atom is electrophile. Okay, and what else we know about it? This is sp2 hybridized. And now these are some of the important stuff that we need to know. So this is sp2 hybridized, and you notice there is something negative. So if something is negative, where it would go? It would go towards positive. Easy peasy. So it's gonna run and attack here. I will color code differently. So it would come and attack here. Oh no, I thought I did green color. Will attack on this carbon atom. Okay, so if this thing attack, you will notice if we don't change anything, it would have 5 bonds because it has 1, 2, 3, 4, and now if the 5th bond comes in, that will have 5 bonds. So in order to maintain the octet, one of the pi electron always gonna move towards oxygens. Oxygen had 2 lone pairs. Now when you move one of these, now it's gonna have 3 lone pairs. So CH3, CO, and it has extra electrons, so it become O negative, chlorine, and then we just added OCH3. Okay, so now we just added OCH3. Okay, so what kind of hybridations we have right now on the carbon atom at the centers? So this is sp3 hybridized. So that's our sp3 hybridized. So if something is sp3 hybridized, what is the structure sp3 hybridized? That's our tetrahedral. So sp3, so which means tetrahedral. So this is called tetrahedral intermediate. Okay, so tetrahedral intermediate with a O negative is unstable. It wants to kick somebody out and go back to its glory days of sp2 hybridized. So if possible, uh, the sp3 hybridized carbon atom wants to go back to sp2 hybridized by removing a group. So I think I should have added one thing. So tetrahedral intermediate with O negative on top. So tetrahedral intermediate with O negative on top. With O negative, not let's say O negative, is unstable, and if possible, it wants to go back. So how it would go back? It would go back if I remove this group. Okay, so if I do that, so that's basically going backward, right? But why this would happen? So this is option A. Maybe I could remove this one. Option B. Maybe I could remove this one. Option C. So let's look at which option is gonna be the best options. So obviously this one's not gonna happen because CH3- is a very bad leaving group. So we can check how can we decide which option is gonna happen. So option A is CH3O-, that is our leaving group. Option B is Cl minus, and option C is our CH3 minus. So which one is our out of these, which options would be most likely options? So the way you can decide is you look at their conjugate acid. So conjugate acid. So what is the conjugate acid of CH3O minus? That is CH3OH. Then is this HCl, and then this is CH4. And then you look at their pKa values. So pKa values of CH3OH is 15.7. SCl is -7, if I remember correctly. CH4 should be around 60s. Uh, so it turns out which one is the most acidic. So HCl is the most acidic out of these. So if something is most acidic, the corresponding base would be the weakest base. So this one is our weakest base. So weakest base means better leaving group. Okay, so never kicked out any of the carbon chain or hydrogens. Okay, so never kicked out any of the carbon chain or hydrogens. So I will delete this. So the reaction that's going to happen is the B, option B. Option B is the one that's going to get kicked out. Okay, so what happened when you do that? So it will look something like this. CH3, CO, OCH3. Okay, so that's the answers. And we got our Cl minus. Okay, so that's our ester. So this is how you can make esters. So basically we removed a group here. Okay, let's stop this video here.